Welcome to a mini Smart Firefighting podcast series, recorded live at the Institute of Fire Engineers booth during the 2024 AFAC show, Down Under in Sydney, Australia. Throughout these conversations, we dive into critical issues like fire safety, emerging technologies, diversity in the fire service, and innovative solutions for emergency response. Enjoy these fascinating insights from leaders around the world on how we can build a safer and more resilient future. Jim Foran, director of PVStop, shares how PVStop de-energizes solar panels during emergencies, making them safer for first responders. He discusses their new drone delivery system for hard-to-reach installations and the importance of training first responders in solar safety. Second pod here at AFAC, sitting alongside Jim Foran with PVStop. Jim, how you doing?
I'm not too bad for Wednesday morning?
I have lost track. Well, technically it's Tuesday afternoon where I normally am, but I guess I'm in the future, so it feels pretty good.
Yeah, time traveler.
It's really feels great. Yeah, it's straight back to the future. I see there's no Cybertruck here, so I'm a little disappointed. So we'll just have to use whatever the other little Tesla truck they have.
Yeah. No DeLoreans around anywhere.
Yeah, I know. So how's AFAC treating you? What's going on?
Yeah, so AFAC's good. I'm here on with our Australian distributor, Fire Rescue Safety Australia. Over on their stand. They've got a range of great equipment, and exciting for us. Our traditional delivery method for our product PVStop is portable pressure vessels similar to a fire extinguisher. But this year we're launching our new drone delivery system. So we've got the new drone on the stand over there, and it's a bit of a monster. It's got a 50 kilo payload capacity. So it's a big bird, and it's attracting a lot of attention. So, having a lot of really good conversations.
How, and I guess maybe even take a step back of who is Jim and what is PVStop? Give me that high level really quick.
Sure. So, Jim Foran, I'm the co-founder and CEO of PVStop, and our mission is to make solar energy safe. So, if you can imagine from a firefighter or first responder perspective, when they turn up to an incident, the first protocol is to save savable life. If there's no risk to life, make safe. So everyone knows firefighters will isolate the power at the switchboard, cut the gas lines, then they can safely go about doing their job proactively. But at an incident where solar panels are featured, as long as it's daylight, those solar panels are continually producing potentially lethal amounts of DC electricity, which forces first responders to treat it defensively, which means, don't put your life at risk, defend the perimeter, and oversee a controlled burn, which is a situation most people don't understand. So our product, PVStop, it's like a liquid blanket for solar panels. The only way to switch solar off at the source is to either switch off the sun or block the light. So PVStop sprays onto solar panels like a liquid blanket or liquid tarpaulin, and immediately blocks the light and de-energizes those panels at the source of power production, allowing first responders to then quickly, safely get on with saving the property, saving lives, and protecting the communities they serve.
And I remember initially when I saw the product thinking, okay, well, you gotta spray this stuff all over the solar panel and you have to cover it completely. And then I was actually wrong in that assumption, where you actually only have to cover a certain portion of it because you're ultimately disrupting the energy chain. Or explain that a bit more for people listening.
Sure. So if you can imagine looking at a solar panel, it's made up of a number of solar cells. Typically in a panel, there's either 60 cell panels or 72 cell panels. Now they're all wired together in series to create a panel, and then those panels are daisy-chained together to create a string. So if you get a 40% strip of coating across the center of the array, you're breaking the circuit, you're interrupting the circuit. So you will still have residual voltage in those cells, still receiving light, but you'll have no amperage. So taking that back a step, basic Ohm's law theory. Volts times amps equals watts, and watts is the power output. So remove either volts or amps, and you have no power. So even that 40% coverage across the center of the array, you might still have 80 or 100 volts of electricity, but you've got no amps. So 100 times 0 equals 0 output.
A squared times B squared equals C squared. Okay,
yeah, exactly.
I got it.
There you go. And that's as far as I'm going on the maths lesson.
Yeah, I was glad that there's people in the world that like you that understand those things. So my youngest brother Declan is just like a energy wizard and there's like perfect test scores and stuff. And I'm like, I can barely, spell my first name. I can barely speak English correctly. So, well, awesome to hear and learn more about, again, the true nuances of PVStop. And then you had mentioned I've seen and heard certain departments, if it can be mentioned in America, using it for that application of responding to a fire, being able to go up and ultimately spray it on the solar panel to deactivate it so it's not generating power. But now you mentioned earlier this idea of the drone, being able to deploy it in areas where maybe a human can't get immediately. Tell me more about ultimately why that's relevant, how it can be used, and sort of some use cases of how it can really be a game changer.
Sure. Well, the drone came about by listening to our customers, and we had the portable pressure vessels, which are a very pragmatic solution. They're in a fire extinguisher canister, so they fit on existing brackets on existing vehicles. So it's a path of least resistance, very easy to use. However, we're getting feedback from the market that for high-rise, for dangerous to access, for difficult to access, the cylinders, the portable pressure vessels, weren't always the right option. So, what can we do? And that's where the idea of the drone came from. So literally the drone can carry quite a significant payload. As I said before, about 50 liters, which, what's that in gallons? 10 gallons?
Honestly, I've been struggling here. Yeah. Everyone's like kilometers, Celsius. I was like, I'm just a stupid American that barely speak their only metric system that we use. So
yeah. So apologies for our imperial friends out there. No. I'm more of a metric guy.
Oh yeah, appreciate it.
So essentially the drone can take off. You're not putting humans at risk, and it can fly across the solar panels. And similar to crop dusting, it's spraying the coating onto the panels once again to de-energize quickly and safely. So for, as I said, high-rise solar farm scale incidents, it's a very quick, effective option. The other really big emerging risk that I'm seeing on the horizon is I've talked about solar panels. They're known as photovoltaic or PV, which is where PVStop comes from. There's a new technology coming out called BIPV, Building Integrated Photovoltaic. So if you can imagine, traditionally solar panels are on the roof, you can have solar tiles, but the latest innovation is like cladding, so commercial building cladding, that is solar panels. So effectively, the entire sides of commercial buildings in the future will be energized.
Is this one of those things that sounds great, but then all of a sudden once it gets on fire, we have a real problem?
Absolutely. So the challenge is, at the moment, the standards and legislation around cladding systems are all based on the fire risk. Now, fire risk is one thing, but none of the existing standards or legislation take into account the electrical risk. So if you can imagine, from a first responder perspective, you turn up to a commercial high-rise structure fire, the cladding may be alight. Now that cladding might not just be alight, the entire side of the wall of that wall might be damaged, electrified cladding. So it's a whole new risk that no one has really thought through. Once again, great technology. It's going to, create clean energy, help the environment, help people to be more productive. But it's these unforeseen safety consequences. And unfortunately, it's the first responders who end up confronting that.
Yeah, they're usually there holding the bag, needing to figure it out, and oftentimes risk their life to go. And there's this constant evolution of new ways to manufacture stuff for buildings or lithium-ion cars.
Yes.
All these things that bring great conveniences and luxuries to human life, but we oftentimes forget what happens when something goes wrong.
Yeah. And that's what we believe our mission is to try and look at the long-term horizon, identify these risks, and create training, education tools that first responders can have in the bag, so they are proactively prepared for these emerging risks and emerging technologies.
You just mentioned training, education tools. Double click into that a bit more. Talk more about what you're working on with that.
So one of the other things when we first released the PVStop pressure vessels, great product, simple to use, product simple, the environment in which we operate is complex. So although we've got a simple solution to a problem, the surrounding issues are complicated. So when you're responding to solar panels, what does a risk assessment look like? What is the fundamental information a first responder needs to know to operate safely? And first responders can't be experts in everything. You know, I consider them the ultimate generalists and the ultimate problem solvers. There's literally hundreds, if not thousands, of scenarios they need to respond to and be able to save life, keep themselves safe, their team safe, and communities safe. They can't be expected to be experts in everything. It's just not humanly possible. So we're finding the product works, but the gap was the training and the education for first responders. So once again, listening to feedback from the customers, we have designed and developed an online e-learning program for first responders and electrical technicians, giving them the fundamental information they need, not just to operate and apply PVStop, but how to operate safely around solar, especially in non-standard emergency response in environments.
That's great. Yeah, I mean, it seems like it's, whether we like it or not, mostly, yes, it's for the better, but the combination of batteries and solar are becoming interwoven into everything we do.
Yes.
And so you're kind of leaning into how to continue to educate on different types, different applications, different before, during, and after disasters. And are these videos and like infographics, like podcasts, like what's in this portal?
So basically, the information is available on our website about the e-learning, but it's made up of 10 modules. Each module is a video of around anywhere between 2.5 and 4 minutes. So it's broken up into micro learning packages. So we understand also first responders, time is precious. They don't want to be bogged down for hours in front of laptops going through dry education. So it's small bite-sized bits of really essential information that they can come and do a bit of the course. If they need to get called away, can go away, come back. And through the course, there's a couple of Q&A sections just to test that they are absorbing the knowledge that they're watching. So overall, the whole course is less than 60 minutes from start to finish, along with some questions. Most people can do it comfortably in an hour and a half total, which can be broken up any way they want. At the end of that, prints off a certificate saying they're now an authorized PV and solar safety operator, which is just once again, a cost-effective method for agencies to not only adopt our solutions, but the training to support their personnel in using it in the field.
Well, I love that, Jim. And it's continued sort of your own selflessness and insight as a founder of knowing that your technology is a piece of the puzzle. There's so much that goes into the overall ecosystem of all this.
Yep.
But then even more than that, there's I found it interesting when we were chopping it up at the rugby game the other day, which still I'm like reeling in terms of how much fun and how epic it was. From the grappling guys coming from the roof, the police helicopter delivering the game ball, to the fake police use of force with the dog hitting the guy, to just an epic league rugby game back and forth. We could pivot podcast completely. What a great experience that was. But talking about just the ways that you're integrating with other aspects of other technologies, from there's, here at AFAC, you look around, like, it's a lot of technologies. You're looking right there. You see a company, Fire Mapper, and there's a data, and there's seen a lot of these different companies that are using data to kind of understand where's the risk, how big is the risk, how we're using satellites now for forecasting, all this kind of stuff. But you would mention some stuff around integrating with some of these other groups around early detection.
Yes.
Tell me more about that.
So once again, listening to customer feedback, when we're rolling out our product into fire departments around the world, we usually find once they've adopted the technology and they're making their members safe, the question starts to arise, why is all the onus on fire departments and first responders to make solar safe? Shouldn't some of this responsibility sit on the shoulders of the PV system owners? And I couldn't agree more. If you're installing a technology, you should be thinking about the consequences of that technology and have plans in place for if something goes wrong. It shouldn't just sit on the shoulders of the fire departments and emergency services agencies. So when you look at those large, like residential is one thing, but when you look at those large commercial PV systems that are now on the roof of most big box structures, whether it be data centers or major DCs, they are big systems. And some of the responsibility for the safety of that should sit on the shoulders of the owners. And I'm seeing the more responsible big multinational companies are taking these risks seriously. The insurance industry is taking it seriously now. Some of the more responsible owners are taking it seriously and starting to put plans in place to mitigate potential rooftop risks. So we're starting to sell the product, both the pressure vessels and the drones, into the commercial sector so they can proactively have solutions in place and plans in place that they can share with the local fire departments. So you've closed the loop on that kind of 360-degree community safety inputs. But one thing, like, no technology is perfect, ours included. PVStop is most effective when you can use it and intervene as early as possible. So the earlier you can apply it, the less damage there's going to be. Now, the problem with these big commercial rooftops is they're high up, out of sight, out of mind. When solar panels do start to develop hotspots, those hotspots can then develop into electrical arcs, and then eventually those arcs then become fires. Now, a lot of those arc events can be hissing and fizzing away for, it can be hours, if not sometimes days, before it evolves into a fire. Now, imagine if we had some sort of early detection system so that as soon as those arcs or smoking or arcing develops, you can alert someone, they can then go and apply our solution, and you're preventing an electrical incident turning into a fire. You're going to reduce the number of fires, you're going to reduce the workload on first responders, and you're going to mitigate that, what I'd call business continuance risk. So what's the cost to a huge data center if that place is out of commission for a week, or it burns to the ground and it's 12 months before it? The costs are astronomical. With early detection, which is cost effective, with our solution, which is cost effective as a combination, you could prevent some of those, a significant number of those fires from happening in the first place. And that's the goal. So that's, we're teaming up with some of the early detection type companies around the world. There's linear heat detection. There's a number of companies doing those linear heat detection solutions. There are now some really interesting companies who are coming up with multifaceted detection, which involves CCTV cameras, smoke detection, infrared detection, all combined and overseen by AI. So obviously you can't have a human just staring at a CCTV camera week in, week out on a roof that's doing nothing. AI can do that. And if something abnormal happens, whether that be smoke, heat, it can alert appropriate people, and then we can intervene early and once again prevent electrical incidents becoming fire incidents.
Well said. And I'm exciting to think about how you're leveraging and tying into this other early detection conversation. And we're talking about that amongst some of the other IFE colleagues here. And it made me think about how you have this response tool that first responders can use to address this challenge and, you know, the wonders, but also challenges of solar panels. And we're here with I got the Institute of Fire Engineers banner above our head right here.
Yep. Hey.
What is IFE to you, and how is IFE like a community organization or institution that's ultimately been something that you work with, and you know what's your hot take on all things IFE?
Yeah. Well, I've got a very soft spot for the IFE, and PVStop are an affiliate company of the IFE. Back when we first introduced our technology, and I was very much still wet behind the ears in this industry. It was the IFE, the engineers, that could see the potential in our solution and really took me under their wing, started introducing me to the right network of people to raise awareness around our solutions, and really helped catapult PVStop around the world. So from those humble beginnings back in 2015, I've always remembered the support they gave me early on when everyone thought we were just crazy.
Started from the bottom, now we're here.
Yeah. Look where we are today.
Yeah. Hey, kudos.
Yeah.
Well, yeah, I mean, it's really just been amazing to watch the IFE ecosystem and the role that IFE can play within Australia, but also the global fire
around
service.
the world. Absolutely. Like they are a global organization of dedicated engineers determined to improve safety around the world. And they're not the largest organization in the world, but they're very mission driven, and I think box well above their weight on the global stage. And it's fantastic to be a part of.
Yeah, they're like the featherweight boxers going into heavyweights and holding their own.
Yeah, absolutely. Yeah. Absolutely.
So any sort of final maybe mic drop moment, or a quote or a challenge or any sort of final words that you could leave us with here today?
Probably the biggest challenge and the next kind of target on our horizon is the insurance sector. So insurers are very aware of these issues, whether it be solar, battery storage. They've got access to extremely good data. And I'd really like to see the insurers working more closely with the first responder communities and organizations, and working with them to once again mitigate these things, be proactive, not reactive. And I suppose that's our next mission as we move into that commercial sector. Commercial sector is driven by profit. Safety is not always the highest priority, although once again, the more responsible companies are very much embracing that safety aspect. But I think insurers should be, and FM Global are a great example of technical insurance, looking at structures holistically. And if buildings and systems are engineered to maximize safety, that should lead to a discount off the premiums, because as commercial operators, if there's an incentive to install safety, financial incentive, they will. And then everyone wins. We can save lives, we can save properties, we can save communities, we can reduce the impact of environmental damage, et cetera, et cetera. So I'd just really like to see the key stakeholders in both the fire sector, the engineering sector, the insurance sector, government, all collaborate more proactively to tackle these new and emerging risks around the world. There are companies like us that'll go out of our way to assist where we can, but it's a community effort. Everyone needs to be involved.
Jim, I really respect and appreciate the entrepreneurial hustle, as well as just the altruistic mindset you have of wanting to help the fire industry around the world. So keep up the good work. And it's been really, really awesome to watch your journey over the years, and just excited to see what happens next.
Yeah, thank you, mate. And I always appreciate the time you take to meet with me and catch up, and the interest you take in what we're trying to do. Like, for that, I thank you.
Hey.
And I look forward to many more to come.
Back at you.
Thanks,
Good
man.
stuff. Thank you. Thanks for listening to this episode recorded alongside the Institute of Fire Engineers during the AFAC show. If you found value in the conversation or learned something new, we'd love to hear from you. Reach out, share your thoughts, and let's keep the discussion going on how we can shape the future of smart firefighting.